All right, so on this particular, we added a new graph now. And make sure you're always looking over here on the titles of the axes, because this says pressure, because this one dealt with volume. You can't tell blood pressure from a volume. So if we take a look at this, the aorta, so how do we know which one's which? Because it's labeled really clearly right here. So the aorta is this gray line, the atrial pressure is this gray line, and ventricular pressure is that guy right there, okay? Maximum pressure in the aorta, so we got to go up to the top, and that'd be 120. Minimum pressure in the aorta, right there, I would say 80. I'd call that 80, all right? Ventricle pressure, now ventricle pressure is the blue line, so that's 120, but it goes all the way down to 0. And the atria pressure, the maximum pressure in the atria, some people, I would say, I don't know, 10 or 15, we'll go 15 today. And then the minimum, it goes all the way down to 0. So clearly, this is the one that's used for blood pressure diagnostics. Because if your blood pressure was 120, then 0, then 120, and like that would be bad. So we don't really want that. Now I did fill these in and I left it for you. So I'm going to, because it does say aortic valve closing, and notice it talks about that right here. Aortic valve close, AV valve opens. So those questions deal with that right there. So let us go through this really quickly. Stroke volume is milliliters per beat. Heart rate is milliliters. I don't know why I put milliliters. It's beats per minute. Okay, so we're going to cross that out, and it's beats per minute. All right, so you already know this. This equation will be on your test. It is exactly on your test, so don't freak out. It will be there. So how do we figure out the cardiac output? So we take 60 beats per minute, that's the heart rate, times 80 mils, that's the stroke volume, and that should be 4,800 milliliters or 4.8 liters. I'll take either one. All right, I think you can figure out this one. All right, I am moving on, so I'm sorry I'm going too fast, but we do need to get to these application questions right here. So now, this is the tricky stuff. So we have an end diastolic volume of 200 and an ejection fraction of 50%. So how do we figure out the stroke volume? So this is 200. So 50% of this 200 is the stroke volume. So you take 200 times 0.5, and that should equal 100 milliliters. Yay. Okay, done. That's super easy. What's the blood pressure? Remember, this deals with volume. Milliliters is volume. It's not pressure. You got to keep that in mind, that milliliters is volume, not pressure. So let's do this person's. The end, so we're going to figure out the stroke volume, we take EDV minus ESV. So 120 minus 80 is generally 40. But how do we figure out the ejection fraction? An ejection fraction, and I don't know why I did that. Ejection fraction equals stroke volume divided by the end diastolic volume. Okay, so this is per beat, and this is how much your heart holds, basically, if you think about it that way. So we're going to take a 40 divided by 120. And that is a third, so that would be 33%. Should we put the 0.3? It's fine. Blood pressure, can you do it? Nope, because we're dealing with volume. Now we're getting down to this one. This is the tough stuff. So you're going to get something exactly like this on your test. Is it the same numbers? Of course not. Okay, calculate the ejection fraction. So we already did that. Now we have to figure out the stroke volume first, the SV. So we're going to take 100 minus 40, and we get a stroke volume of 60. Woo-hoo! Okay, ejection fraction, we're going to use this equation right here, and I'm going to change colors so that you can see what I mean. So we're going to use this equation right here. So we're going to take 60 divided by the end diastolic volume divided by 100 equals 60%. That's pretty good. Does that fit in our 55 or 50 to 65%? Of course it does. Calculate the cardiac output. CO equals stroke volume times beats per minute. I forgot the beat. Okay, so we're going to take stroke volume, which is 60, times our beats per minute, which is 100. We get 6 liters. I thought that's 6,000 milliliters. That is what 6 liters is. I'm just going to go through these really quickly and explain as I go. You're going to have to hit pause if you need to write these down. So once again, it talks about 50 to 65% is what we call normal. Okay, so we've got an end diastolic volume of 120. 55% of this gets actually pumped out. So we got to figure out what the stroke volume is. So we take 120 times 0.55, and let me find the notes. I got it right here. So 120 times 0.55 equals 66 mils. So how do we figure out the cardiac output? We take 66 times 72. Why 72? Because it says right there, that's the beats per minute. Equals 4.75 liters per minute. Okay, that's good. That's a pretty healthy person. 55% is really a strong amount of blood being pumped out. Let's do patient number 2. We're going to take 40% of this 120. So 120 times 0.4, and that equals 43 milliliters. All right, we need the cardiac output, so 43 times the beats per minute. So that would be 72, which is 3.46 liters. Okay, what if I wrote 3,000? Okay, you're fine, but 3.46 liters. And this person, just really quickly, it's 25% of 120, so 120 times 0.25 equals 30 milliliters per beat. And let me do per beat. And so what we get is 2.16 liters. Obviously, you can see 2.16 liters, that's not very much. That person's heartbeat isn't really doing well. The end, you need to figure these all out on your own, okay? And the key is you got to figure out the cardiac cycles on there. I am checking this, so there we go.